Now we move on to our second conic, which is about hyperbola. So the second type of conic we're going to talk about is the hyperbola. So just like the ellipse, it's going to be defined from a fixed So the next type of conic we're going to talk about is a hyperbola. So just like we defined both the circle and the ellipse by some type of constant proportion or constant sum of distance between some fixed points, the hyperbola is going to be the same way. So in this case, the hyperbola is the set of all points in a plane such that the absolute value of the difference of two distances from two fixed points is constant. And those two fixed points again are called the foci. So in the last one, it was the sum was a fixed constant. Now it's the difference is a fixed one. And just like we did with the ellipse, we're going to start with figuring out what's going on at the center being at the origin, and then we're going to shift it off to a different center HK. So we likewise have two different forms. In this case, we're going to see x squared over a squared minus y squared over b squared, or the y is going to be positive. Here, it doesn't really matter which number underneath is bigger. That's just going to help us with the asymptotes themselves. But when x is positive, it's going to tell you it opens along the x-axis or in the x direction when you shift it. When y is positive, that tells you it opens along the y-axis. So we have a special thing here that's called the transverse axis, and that's going to be in that same direction it opens along in. So most of your important information is going to be along the x-axis, and likewise here, the important information is along the y-axis. So let's go ahead and plot both of these at the same time. We're going to start with that center, which is right here at the origin in both cases. Now, it's opening along the x-axis, so I'm going to move left and right, again, that same distance a. So from here, we go out a distance of a, out a distance of a. So this will be the point a 0, and here it's 0, negative a. In the case that it opens along the y-axis, you go up and down a distance of a. So this is 0, a, 0, negative a. So this point will be negative a, 0. When it opens along the y, you go up and down a distance of a. So 0, a, 0, negative a. Now your foci are also going to lie in the same direction, but we have two other things we have to draw first. So one of the unique things about hyperbolas is you have asymptotes that this thing is going to come near. So the asymptotes are going to go right through the center. So one line's going to be here, one line is going to be here. The way you actually find the equation of the line is, since it's going to go through the origin, it's just the slope times x. You take the value under y, divide it by the value under x. Here it's the opposite slope, so it's the value under y over the value under x. And it's just like your normal slope, kind of the rise over run, dealing with the y's over x's. Same thing here, you're going to have two asymptotes that are going to go through that center point. And it's still going to be the value under y, which in this case is a, divided by the value under x. Then you have the negative version, value under y, value under x. So in both cases, you can think of the slope of the asymptotes as the y over x, like our normal slope. Now, our actual conic is going to go ahead and hug those asymptotes. And so it kind of looks like we're creating two parabolas together. And here you go through that vertex, and then you go through this other vertex here. So unlike the ellipse, you're actually going to have two foci, and they're going to be inside each of these parabolas. So your foci will be here. And you're going to go left and right that distance of c, so c0, negative c0. Here you go up and down the distance of c, so the value of c is going to be larger than a in this case. Okay. And then here, if you want to see what that transverse axis is, it's going to be in this x direction, and it's really just going to be the thing that connects these two, and the transverse axis would be here. So we'll color code these. So it's still telling you where that important information is going to lie. Now, to find your foci in this case, or to find that value of c, we get to actually use the Pythagorean theorem itself. So the way I like to remember this is this equation has a minus in the middle, the value of c has a plus in it. For the ellipse, that's a plus in the middle, and c has the minus in it. So we can keep the same type of idea as us graphing ellipses and coming up with equations of ellipses. They have a lot of similar structure to them. So that value of a tells you how far you're going left and right. When you're trying to come up with the equation, graph the stuff that's given to you to figure out what the form is going to look like. So here we're given some information. We're given the vertices, and we're given one of the asymptotes. So what we want to do is graph everything to find the direction that this is going to open up in. So we need to come up with our coordinate, and I'm given one of the asymptotes, which is 2x. So that definitely goes through 0, 0, and goes through 2, 0, or 1, 2, and then 2, 4, and it has this shape here. And then we're going to plot our vertices, which are at 4, 0, and negative 4, 0. So immediately I know that the transverse axis is along the x-axis, and it's going to have the form where x is positive because my vertices are here. So I've got to have to open in this direction. I can't open up and down. Okay. With this, I also know that this is going to be centered at the origin. So I get my other asymptote here, negative 2x. And the center, because it's occurring halfway in between these, is that point at 0, 0. So I know that a is equal to 4. So in this equation, I can put a little bit of the information that a is equal to 4, the value under x is going to be 4 squared. But I don't know exactly what's going underneath b, or underneath y. So what I can do is I still have that second piece of information that I haven't used to come up with this equation. So we're going to use the slope of that asymptote to figure out the value of b. So this is going to be what's underneath y divided by what's underneath x, just like our typical slope. So b over a is going to equal 2. Since I know that b is then 2a and a is equal to 4, I can figure out that my value of b is equal to 8. So plugging this in, we get the equation in the hyperbola will be x squared over a squared, which is 16, minus y squared over b squared, which is 64, equals 1. Okay. If you wanted to figure out what the foci were, your value of c squared would be 16 plus 64, which is 80, or c equals root 80. So your foci would be further along the x-axis here and here. So those would be located at plus or minus root 80, 0. Okay. Now let's go ahead and do the opposite. Let's be given the equation, and we want to come up with all of the important pieces of information, including the domain and range. And then we're going to utilize a graph. So again, you don't have to find everything from formulas. You can graph it simultaneously as you're finding all the pieces. So the one thing we have a little bit of a problem with is we don't have a 1 here, and you need a 1 there to be able to pick all your information. So if you just divide by 9, that gives you the same exact equation, and now I can utilize this to figure out my actual pieces of information. So my center is at 0, 0. My y value is going to be positive, so that tells me my transverse axis is going to be along the y-axis. My value of a is 3, because that's what's underneath y. B is 1, and I can use that to find c. So c squared is a squared plus b squared, which is 9 plus 1, which is 10. And again, it's a distance, so I don't care about the negative square root. I get c is equal to root 10. And I can also write the equation of my asymptotes right now. So you get y is equal to plus or minus the value underneath y, which is 3, the value underneath x, which is 1, times x. So you get plus or minus 3x. So we're going to go ahead and graph all of these, and then we'll go ahead and pull all the information together. My center is at 0, 0. My asymptotes are 3x. So that's going to be 1 asymptote here, roughly. Then I've got negative 3x, which will go right here. So this is my second asymptote. Y equals 3x, y equals negative 3x. Then from the center, the value underneath y is 9, so I go up and down a distance of 3. And that's going to tell me that my vertices are at 0, plus or minus 3. Now to find my foci, I have to go up and down a distance of root 10, which is a little over 3, so we'll exaggerate it. Up and down a distance of root 10. So my foci are located at 0, plus or minus root 10. And then to actually get my graph, we go ahead and draw our 2 parabolas in to form our hyperbola. So here is our graph. And from this, now I can actually figure out what my domain and range are going to be. So my domain, you can figure out whatever value of x you want. You're going to get an output because those things continue on forever up and down. My range, however, I can't equal anything in between here. So it's from negative infinity to negative 3, union 3 to infinity. So in this case, you've got to be a little bit careful with one of these variables. If it opened along the x-axis, your domain's going to be slightly altered because you're going to have a gap between these two. So just be careful with that. And the same thing if you have to deal with that square root, it's only going to end up restricting part of it. So you're only going to get a piece of the hyperbola, whether it's the left or right. Okay. But now we're going to go ahead and we're going to take this thing and shift it to give it a center HK. All that's going to do is shift it. You plot that center to get your vertices. You're going to go up and down a distance of A or left and right a distance of A. To find your equations of your asymptotes, you're going to replace y by x minus h, and then to find your asymptotes, you're going to see we're going to replace x by x minus h because that's what shifts the center, and you'll replace y by y minus k. So we're going to just look at one specific example, go ahead and plot it, and figure out all those informations. So we're going to consider the case where we have the x being the positive term and the y being the negative term. So your center is going to be HK. It opens in the x direction because the x is positive. And so to figure out all of our pieces of information, I'm going to first plot that center. You can go ahead and ghost in the same dotted lines to help you out if you need to, but this is our new center. To find our vertices, because it's opening in that x direction, you go ahead and go left and right a distance of A. So you're not affecting the y value at all, you're just changing that x and y, or that x direction. So to actually find the vertices, you're just going to add and subtract in the x component. The y component stays untouched. Same thing when you find the foci. You're going to go left and right from this point. So it would only to find your equation in the asymptotes, that's the one that's a little bit harder. So it still deals with the value under y and the value under x being your slope itself, but you've got to go ahead and replace the y by y minus k and the x by x minus h. So these two are just being replaced to shift that center. So really you can think of this as y is plus or minus b over a, x minus h plus k. So you've got two equations of asymptotes. And then your actual graph would look something like this. Okay. Your foci will be from that center. You go left and right, that distance of c. So again, it's only going to affect that x component. So it seems kind of messy and confusing because you've got all of these different variables going on. Again, just think of how these are graphed. Plot the center, everything is going to move from there. You can always reverse engineer these asymptote equations if you need to. Knowing the center and knowing the slope is that y over x. So let's go ahead and work with this equation. We're going to find the center, the transverse axis, our vertices, foci, asymptotes, domain, range, and we'll graph. And again, we'll graph simultaneously while doing this. Problem is right now, this thing is all over the place. I don't have something squared minus something squared. I do have that my value of x is positive, so it is going to open in the x direction. But I've got to go ahead and I need to complete the square on each of these variables. So I'm going to group the x's, group the y's, move the 16 over. So first, I'm going to take out a 4, and that's going to leave us with x squared minus 6x. And then over here, I'm going to go ahead and take out that minus sign, and that's going to leave us with y squared plus 4y. And on the right-hand side, I've still got 16. To complete the square on the x's, I've got to take negative 6, divide it by 2, and square it. So I need to add 9. But I really didn't just add 9. I added 4 times 9. So on the right-hand side, we're going to add 4 times 9. For the y's, you need to add a 4 in here. But again, you didn't add 4. You really added negative 1 times 4. So on the right-hand side, we'll subtract 4. So this gives us the equation 4 times x minus 3 squared minus y plus 2 squared equals positive 16. And to put it in standard form, you need a 1 over here, so divide everything by 16. It'll make that 4 cancel, and you get a 4 up top, 16 under the y terms, and then a 1 on the right-hand side. So now I can go ahead and pick off my center. It's going to be 3, negative 2. The x is what's positive, so it's going to open in the x direction, and that tells us that our transverse axis is going to be parallel to the x-axis. It won't be on the x-axis itself since we shifted that center. Our value of a is 2, and the value of b is 4. So that value of a is going to tell me how I move left and right. And then from this, I can figure out what c is. So it's a squared plus b squared. So we get c is equal to root 20, which you can simplify, but you don't have to. So now I'm going to go ahead and start plotting things and then come up with all these extra equations that I wanted. So first thing we're going to do is plot the center, which is at 3, negative 2. So everything is going to move off of this center point. So we're going to go ahead and draw in some ghost lines to help us out. Now, to figure out my vertices, I'm going to move left and right a distance of a. So what's underneath my x was the 4. So I move left a distance of 2 and right a distance of 2. So my vertice, you can just pick off the graph. It's going to be 1, 2. So 5, negative 2. Back 2 would be 1, negative 2. Or using those equations, it's 3 plus or minus 2, and the y-coordinate stays untouched. To find your foci, you move left and right this distance of c, and that's about like 4.5. So that's 1, 2, 3, 4, and a little bit more, so it'll be around here. And then we go 1, 2, 3, 4, and a little bit more right around here. So here is my point. Okay. So our foci are going to be at 3 plus or minus root 20. The y-coordinate stays untouched. Now, to find the equation of your asymptotes, you can do a couple different things. So this is the value that was underneath y. This is the value that was underneath x. So your slope will be 4 over 2, which is 2. And you'll get the plus or minus version. So from this center point, you would go up 2 over 1, up 2 over 1, and here would be 1 asymptote. Okay. So if you wanted to reverse engineer the equation of this line by using this point and the slope, you absolutely could. Your other slope will be negative 2, so you go down 2 over 1, or you could go up 2 to the left 1, and this would be your second line, which again, you could reverse engineer. Or if you want to stick to those formulas, you get y is plus or minus the value of y over the value of x minus the center coordinate, and then you add the y coordinate. And then you could simplify both of these to get the lines 2x minus 8 and negative 2x plus 4. Then the last thing we have to do is just actually graph this. So our hyperbola opens in the x direction. Doesn't need to be perfect, but it'll be close to here. Okay. So the last thing we're going to do is similar to the ellipse. We talked about the eccentricity, which was that fixed ratio because those values of c and a were constant. Eccentricity of a hyperbola is exactly the same thing. There is a fixed ratio c over a, and that's going to tell us about the properties of this. So you'll see So the last thing we're going to go over is dealing with the eccentricity. So we saw for the ellipse, the eccentricity was that fixed ratio c over a, because the values c and a don't change. Same type of thing here. We're going to define the eccentricity in the exact same way. So it's still c over a. For an ellipse, it was something between 0 and 1. For hyperbola, we're going to see that the eccentricity is always going to be greater than 1. So this will help you define what that conic is specifically going to look like. So in this case, because the value of c is larger, because like here, this is your distance a, this is your distance c, since it's pushed inside, we get this relationship. So you're going to get 0 is less than 1, which is less than c over a. So the eccentricity of a hyperbola is always going to be something greater than 1. So if you're given the eccentricity, you'll be able to see what type of shape you actually have. So we're just going to do one quick example. We're going to find the eccentricity of this hyperbola. So I've got x squared over 9 minus y squared over 4 equals 1. First thing I got to do is I got to figure out what is c. So that's going to be a squared plus b squared. So it's root 13. So if I want to find our eccentricity E, which is nice and bold face, it's going to equal c over a, which is the square root of 13 over a, which in this case is 3. So if you go ahead and plug that into a calculator, you're going to see it's about 1.2. Okay. So the last thing we're going to do with these conic sections is really kind of combine the two together and try to identify, what am I dealing with? Am I dealing with an ellipse? Am I dealing with a hyperbola? Parabola even, because that's another type of conic section, which we've dealt with already before. Or do I have like a circle, or do I have nothing?